Right, welcome back, and now we are on video 5, which is actually the last video of the IPv4 series before we get into the actual big stuff, the subnetting. So all of this stuff is really the foundational stuff, understanding how where it came from, how it works, why it does that, and so forth. Once we finally wrap up now with what is RFC 1918, which is what we're going to be covering inside this video, then moving forward, we're going to be discussing subnetting. I'm going to try and create as many examples as I can for you. It's one of those things that very few people get the first time they see it. It is a light bulb moment as well, meaning that very often, and I've taught this for about 20 years now, and the amount of times where I see faces in a room and they're all staring at me like, man, you just crawled out of cheese. I have no idea what you're talking about. And then literally 3 seconds later, light bulb moment, they get it. And they're like, oh man, this is so easy. Why is everyone else struggling so much? It is a eureka moment, right? You'll battle for a little bit and suddenly you'll just get it. And that is what subnetting all is about. So we will explain how subnetting works, and that is coming up after this. But RFC 1918, this is a pretty short section. It's nothing too hardcore. One of the things that I had mentioned in the previous video was that we had to come up with a whole bunch of clever tricks on how to allow the longevity of IPv4. So how can we come up with ways to allow us to reuse IP addresses? And one of those ways was to do this whole idea here of classless addresses. I also mentioned something called NAT, Network Address Translation, and that evolves into things like PAT as well, Ports Address Translation. But RFC 1918 was one of the most important changes to IP addresses to allow the longevity to actually remain. So let me explain what it means. Initially, when IP addresses were available, right sort of in their invention phase, if I went to the IANA or the Internet and said to them, hey guys, look, I need an IP address, they would have said, well, how many do you need? And I would have said, well, I'd kind of like a Class B address. And they would have given me one, right? They would have charged me a monthly fee or whatever it may have been, but I would have been able to get a full Class B without any questions. Bad news with that is we ran out of IP addresses very quickly. So as a corporation or as a company or even as a home user, I need an IP address I can use internally without having to apply to a governing body to say, hey, what can I use? Can I buy it or any of that? So RFC, which stands for Request for Comment, is how the entire of the internet has been founded, which means that if you have any suggestions for how the internet could improve, right? And by internet, I mean the protocols. I mean TCP, UDP, IP addressing, you name it. If you come up with a eureka moment where you go, I have a better way to do that, you can send a request for comments from a governing body that will look at it and go, you know what, this guy's actually onto something. Now, if it becomes an official standard, it gets a number. So someone had come up with this idea, and it became number 1918. So RFC 1918, here it is. We are allowed to use an IP address for private use. The private use IP addresses are anything that starts with a 10. So that is 10. And it actually is anything. So 10.x.x.x, right? Put the entire range down. I am allowed to use this IP address free of charge, no questions asked, whenever I feel like it, as long as it never exists on the internet. That's the rule. These are private IP addresses, not public IP addresses, right? And I'll show you some differences in a few moments. What else can I use? I can use 172.16.0.0 up to 172.31.255.255. Right, so that entire range where 172.16 up to 172.31, that entire block I am allowed to use free of charge, no questions asked. And anything that starts with 192.168.anything.anything. So those three ranges of IP addresses I am allowed to use completely free of charge, no questions asked, and I don't have to apply for them. But the golden rule is not allowed to exist on the internet. So here's what I want you guys to have a look at, and give this a try for yourself. If you jump onto your computer, open up a command prompt, and say ipconfig, right? It's assuming you're running a Windows box. If you're running a Linux or a Mac, it's ifconfig. It will give you the same result. So wireless network is what I'm using here. Oh, look at that, 192.168. Yep, there's that range. Allowed to be used, free of charge, no problem. But hang on a second, I am on the internet. Although I am on the internet, my IP address has to be translated. My IP address gets translated from this 192.168.1 into my public IP. And my public IP address changes because I have a service provider that does dynamically change my IP address. Here's how you can find out what your IP address is. So there are many websites that you can actually go and check this out real quick. The one that I use the most is www.whatismyip.com. If you go to that website, it'll actually show you what your public IP address is that is being utilized. Now, in a case like mine, where I'm at home with a lot of devices at my home office, all of them are going to share that single public IP address on the outside. Internally, inside in my home office, everything is going to have an IP address of 192.168.1, and then that will be converted or translated into the public IP address that my ISP, my internet service provider, will give me. Now, this translation, this conversion, is called NAT, Network Address Translation, and it is most definitely a topic that we will be creating a video for on our YouTube channel. So stay tuned for that. I'll put a little bubble here once I've actually physically published it live. So NAT will allow us to do that translation between the addresses. Now, the final little bit that I'm going to show you here while we're on this point is, of course, understanding how communication works is also to understand that as humans, we don't often think about IP addresses, right? I mean, I didn't tell you what the IP address of that website is. I gave you its domain name. Now, one of the other big things here is to understand that there is a protocol called DNS that will change what is my IP.com and convert that entire domain into its IP address. So the IP address of whatismyip.com is 104.27.193.92. Now that IP address is not in RFC 1918. It is a public IP address, which means it is allowed to exist on the internet. If we were to ping any other type of address as well, let's go for something like cisco.com, for example. There is an IP address of Cisco. They're using Akamai, so they're going to be using a content distribution, so that IP address will be different worldwide. If I try and do something like ping Google, for example, similarly, that'll probably be different on a worldwide scale, depending on where you happen to be. We can ping www.youtube.com, and it's DNS, domain name resolution, that is translating a user-friendly version of the domain, youtube.com, or whatever it is, and converts that into its actual public IP address. But make no mistake, the communication between my laptop and YouTube is done through IP. Right? As a human, I need this cool, easy to remember name, but as computers and as IT and technology, it only cares about IP addresses, and that is what is used to communicate from one machine to the next. Brilliant. So hopefully now RFC 1918 makes sense, and you know what that's all about now. And this is about IP addresses that we're allowed to use internally. Now, I challenge you to go have a look at your own companies, your own homes, your own wherever it is you are right now, and confirm for me that you are using one of those addresses. Now, unless you work for a government agency, it is highly unlikely that you will have something that is not one of these ranges inside your address range. So you'll be using one of these inside your company for sure. Good. That brings us to the end of RFC 1918. What is coming up next? We are now going to dive into what is subnetting, how to slice and dice these different addresses, and I will go through some examples with you guys, and probably split those up into multiple videos so we can use them as a sort of a lab as well. If this video helped you in any way, shape, or form, hit the like button, and of course we'll kick in with the next video on subnetting.